Alright, so today's lesson is going to be on isomers. Alright, so what is an isomer? An isomer has the same formula but a different atomic arrangement. And since it has a different atomic arrangement, it also therefore has different properties. All right, and let's take a look at C3H4 as an example of an isomer. All right, if I wanted to draw C3H4, 3 times 4 is 12 plus 4, 16. I can have 16 electrons. Now, I know that carbons always go in the center. And I have 4 hydrogens. So I've put in 2, 4, 6, 8, 10, 12, 14, 16. All right, so here is my skeletal structure, and I see here that my carbon in the center does not have 8 valence electrons, so I can erase a lone pair and make it a double, and I'm going to also erase the lone pair on this side and make it a double bond as well. So this is one way that I could draw carbon. All right, and what I've got is carbon right here. So this is the 3D structure of C3H4, C3, and then I have my 4 hydrogens on the outside. Now, another way to draw C3H4 is I can, again, put my carbons in the center. And something like this, where there is a triple bond between these first and second carbon here. All right, so I have this triple bond. This is an isomer. It still has 3 carbons, 4 hydrogens, with a total of 2, 4, 6, 8, 10, 12, 14, 16 electrons. And over here, 2, 4, 6, 8, 10, 12, 14, 16 electrons. So everything is the same except the way they are arranged. An isomer can only be formed from something, or to determine if it's an isomer, a bond has to be broken somewhere and remade. So if I wanted to take my first structure of C3H4 and make my new structure, I would have to break bonds. I'm going to have to break this double bond and make it a single bond. It's going to have to come over here with my carbon and form a triple bond. And then this hydrogen I removed from the carbon comes over here. So you see, I had to actually physically break apart and rearrange. That is an isomer. This is not an isomer. This is a mirror image. A mirrored image, if I was to draw this as its mirrored image, okay, this is a mirror image. Here we are. My first picture, my second picture. All I did was move my compound to the different mirrored image. I did not have to actually physically break anything off and rearrange it like I did in order to get from my first structure to my second structure. Now let's look at how many sigma and pi bonds there are in these two. Now, I've printed this off from our website, Socratic, all right, to help us. So I got this from their website. but let's look at what a single bond is, all right? So a single bond contains what we call a sigma bond, and that's where we have an overlapping of orbitals. And now remember, we've already talked about hybridization. So when two orbitals directly head-on overlap, kind of like a head-on car collision, they hit head-on, that is what we call a sigma bond. Now, a pi bond, for example, is when we have a side overlap. So here's a triple bond, and you can see our sigma bond in the center right here. All right, that head on. But we also have an overlapping from the side and from the side here. So a triple bond has a pi bond down here where the side orbitals overlap and these side orbitals overlap. So two total pi bonds. And then that head on, which is our sigma. So if we look here at my diagram, I have my overlapping of the side orbitals right here. All right, so these are both pi bonds, and then this bond down here, this is my sigma bond. All right, so a single bond has one pi. I'm sorry, I just said that backwards. A single bond has one sigma. A double bond has one sigma and one pi. And a triple bond has one sigma and two pi bonds. So let's come back up here. How many sigma bonds do I have? Let's count all of the single bonds. 1, 2, 3, 4. Plus, each double has a sigma. 5, 6. So this has 6 sigma bonds. How many pi bonds? Each double bond has one pi. There are 2 double bonds, so I have 2 total pi bonds. Now, if we look at our second isomer that we drew, how many sigma bonds do I have? I have 1, 2, 3, 4, 5, 6. And how many pi bonds do I have? A triple bond has 2 pi bonds. So I have 2 total pi bonds. All right. So let's look at our Lewis structures for molecular compound sheet. And let's look at isomers, all right? Isomers here. All right, and let's draw C2H2Br2. There's a couple of different ways we can draw C2H2Br2. So go ahead and pause this video, see if you can't draw it. And you have a hint there, there are 3. All right, so let's draw. You may have drawn it to look like this. Okay. Or you may have drawn it to where our bromines are both down and our hydrogens are both up. Or you may have drawn it to look something like this. Okay, so here's our 3 different isomers. And let's take these isomers and let's look at them in terms of our structure. All right, so let's look at the first one. I've got BRs going across from each other and the H's going across from each other. And so here's my structure. Maybe I should zoom out a bit so we can see. Whoops, that's the wrong way. Okay. So here we go. So I have my BRs and my hydrogens. Miss Colson, I put my hydrogens where you put your BR, your bromine, and my bromine where you put the hydrogen. Is that an isomer? Nope. Mirror image. I didn't have to break anything apart. So that's okay. You could have drawn it that way. If you had drawn your hydrogens where my bromines are and your bromines where my hydrogens are, that's perfectly acceptable because, look, that's the exact same thing. This molecule is the same. You ready? Let me put my bromine back the way I put it. Boop. Flip. And there it goes. Okay? So this is the same. That is the same molecule. So this C, BR, BR, H, H. This is the exact same thing as this. If BR is the purple and H is the white, check it out. BR, now let me just do what? One more time. All I did was flip it. I did not break any bonds. So these are not isomers. They are not isomers. This is an isomer though, because if I want to get both hydrogens on top, how do I have to get both hydrogens on top? I have to what? Literally break apart my structure and I have to rearrange it. The fact that I had to break apart my structure and rearrange it makes it an isomer. Miss Colson, I drew mine like this. Is this another isomer? I drew mine like this. Is this another isomer? And the answer is no. Watch what I do. Just flip it. I don't have to break any bonds, so nothing's being broken here. So I'm simply flipping my molecule. It's the exact same thing, not an isomer. All right. If I wanted to get my carbon-carbon where both of these bromines are now on the same carbon. So I want both bromines on the same carbon. What am I going to have to do? I physically have to break apart and rearrange. So the fact that I had to literally take bonds apart and rearrange them, it is an isomer. Miss Colson, I drew my isomer like this. Is this another isomer? Is this, are there really 4 isomers and not 3? All right, watch what I do here. I just flipped it. Yours is simply a mirrored image of mine. They are the exact same thing. I have not broken any bonds. I have not rearranged anything. So this is a mirror image. It is not an isomer. Now, isomers can have one of 2 formations. They can have a formation called the trans. Like if you go transatlantic, you go across the Atlantic. So we have atoms across from each other. Or it can be a cis, where the atoms are side by side. So 2 different types of isomers there.